Here is a simple 535 experiment that I have on my desk. I'm looking at a single 4 to 20 milliamp input to the 535, and I will go through the settings of the 535 in a moment, but in summary, I've sent it to the simplest type of PID, which is P, and in the tuning there is a PID trip set, and the number of PID is 2, and so when the deviation gets to 1, so if we go, we're set 0 to 1,000 here. If we have a deviation of 1, it will switch from normal PID proportionate mode, just proportional, to a very hard P of 1,000 when it gets above the deviation from the set point. So I'll just show you what happens as while we're operating. So this is your 0 to 1,000 level, and this is the output in percentage, the control output. So if, say, for example, we were at 4 milliamps, we'd have 4 milliamps here, 4 milliamps on the output, and then if we went up in increments, seven, 8, 9. You can see it's basically repeating the output because of the settings, which is good. And then if I go to 11.5, then take it up a bit more slowly. If I go here, I'm just going up by 0.1 of a milliamp at a time. When we get to 50%, we are okay in PID 1 mode. And as soon as we go over the threshold, the output drops off and it gets into PID 2 mode. And the control 1 has disappeared as well. And now it's come back. So I need to investigate what's causing that out 1 to disappear. But above that set point, we have hard clamping down to 0% because of the PID settings. And that's kind of proving the point that it is possible to go to pretty much 0 on the output based on deviation from set point. So, and then going back below, it's immediately automatically gone back into the proportional control. So if I take you through here by clicking the display button, our set point is 500. We could try another set point shortly just to prove the point. The deviation is 0 and it is directional. So if I go below, it goes negative. If I go above, it goes positive. I need to find out why that control disappears at this setting. That may or may not be indicating that we're going from one PID to the other. We've also got our output. So in the settings then, I'll just go through quickly. The tuning menu is accessed by pressing the menu button. and then you can scroll through the settings with the menu button. So power back is disabled. So prop band 1 set to 100%, and that's given us our proportional output for this testing scenario. And our manual reset is 50, and on the first PID. Set the number of PID to 2, and the PID trip, so the reason it switches from 1 to 2 is the deviation value. And trip 1, it must be set to a very low number for it to work. I found. I think this refers to the trip value when the first PID mode will be used, and then we get our second prop band value, and I put that to the highest output it will go, and this is 0, and this is our trip threshold that causes the second PID to kick in. So that's deviation of +1. You could also set that to a minus number if you wanted to. It's not absolute. So that's the tuning menu settings. In order to access the other settings, you must be in manual mode, and you press fast and menu at the same time, and then you're in the config menus now, and then pressing the menu button. These are the settings that I've got at the moment for this example. Line frequency 50 Hz, source PV1, and this one has 2 alarm outputs, which are currently set for not doing anything, and it's also got a 4th output, which is actually can be used as a retransmit, a analog output. Your model won't have those outputs if you're using the loop power option, because the loop power, I believe it requires one of those output cards per channel. The range 4 to 20. So I press fast and menu to get to the next menu, which is the PV1 input, and pressing menu cycles through. So it's just set 0 to 1000. So that's pretty straightforward stuff. And pressing fast and menu again gets to the control menu, and I've just set for now the algorithm to P. So I don't believe you can change. So here you can choose P, PD, PI or PID, but I don't think you can have it so you switch from PI mode as the first PID setting and then P mode as the second PID setting. I think both of them would be P and I, but you just choose values that gets you closest to just the P and I mode that you want. So source PV action, you can choose direct or reverse. I've got a direct for this PV break. You can look up some of these settings in the manual if needed, and that's pretty much it. And then you can configure other menus by scrolling through, and that's it really. And to get out of the settings, you press display and then hit manual, and then you'll be back in PID mode. So I said I was going to try a different set point. So if you hold fast and press the up button at once, you can skip through the set points a bit quicker. So I set that to 600 now, so the output should do something a bit different. See, deviation is minus 500 at the moment, and that's what the output is doing. That's because I've set it to PID mode. Let me put it back into just P for this experiment. Config, let's go. Oh, gone too far. Gone too far again, because I'm trying to do it with one hand. Control. So here we go. Let's set that back to P, and then go back, and then we'll try again. So yeah, back to our proportional output. So our set point is 600 now. Let's make it 603 just to show that it's different. And then we can observe the outputs are stable now because it's just in P mode, not PID mode. I'm going to go to here, and let's just ramp it up until we let's have the light on. Let's ramp up until we get close to that 600 threshold. Still, the output is proportional to the set point. So we're at the set point now, still in proportional mode, and then as soon as we go over, it's clamped down to 0, which I believe is kind of what we're trying to achieve with this. And then coming back down again, let's just go up all the way just to see. If I type in 20 and there, see the output's at 3.9%, so that'll be a very low, sort of 4 point something milliamps. And then if I go back down to where we were, and then I'll slowly go down below just to prove that it kicks back in at the value we said. So there we are. As soon as we got back below the set point, it started to control again. And that's the end of this video. Thank you.